let's prove that in any ordered field, between any two distinct elements, there's at least one other element. So let's call our field F, and let's pick two elements in our field, call it A and B. And without loss of generality, we will say that A is less than B. So let's think of it. Let's say we have, let's look at it, let's say our real numbers. What is a number between A and B? Well, an easy option is to pick just the average. We know that the average will lie in the middle if our field is a real numbers. So this is a good candidate. So basically what we want to say is that A plus B over 2 is between A and B. That's what we want to show. So we'll do this in two steps. First, we'll say that A is less than A plus B over 2. And the second case, we'll say that A plus B over 2 is less than B. Okay, so first, let's consider, so let's subtract both sides by A plus B over 2. Let's consider this. What is true about this? Well, I can multiply top and bottom by 2. And then I can subtract this and get that A minus B over 2. And is this less than 0 or greater than 0? Well, we said that A was less than B, kind of as our assumption. So if I subtract both sides by B, I get A minus B is less than 0. So if I divide both sides by 2, I find that this is less than 0 as well. So then we go backwards. We know A minus B over 2 is the same thing as A minus A plus B over 2, which is less than 0. And so A has to be less than A plus B over 2. So that's what we wanted to show. So that's good. Now for the second case, we're going to approach it the same way. We're going to consider A plus B over 2 minus B. So what we're doing is basically subtracting the B over here. And then let's get a common denominator and subtract this. We have A plus B minus 2B is A minus B over 2. And here A minus B we said is less than 0. So this thing is also less than 0, because if you divide by 2, it's also less than 0. And recall that A minus B over 2 was this thing above. It was A plus B over 2 minus B, which is obviously also less than 0. And then adding B to both sides, we get A plus B over 2 is less than B. So what we've shown is that A plus B over 2 is between A and B. And what this means is we have shown that in any ordered field, between any two distinct elements, A and B, where A is less than B, there exists at least one other element. In this case, we said the arithmetic mean of A and B, which is just A plus B over 2. And so this completes the proof.